Hi students. All right, so today we're going to be going through how to write and simplify ratios. And this is just a quick refresher. All right. All right, so we're presented with the first case. All right, a bus has 30 passengers, 10 are females, 20 are males. What is the ratio of A, males to females? Of course, ratios compare the values of two or more entities. Let's remember that. Ratios compare the values of two or more entities. So we're comparing the values of the number of females with the number of males. All right. So 10 are females, 20 are males. So the ratio of males to females, you write the males first. So that's 20. And the females 10. So that's 20 to 10. That's the ratio of 20 to 10. Now, if it is that we need to reduce this to a smaller ratio, meaning let us find the highest number that can divide into both 20 and 10 at the same time. So that would give us 10, right? If we divide both sides by 10, like so, that means 20 would be reduced to what? 2. And 10 would be reduced to 1. So this is saying for every 2 males, there is 1 females. Or there are twice the number of males than females. Alright? So when we reduce the ratio, we can be able to clearly see, we can clearly compare the values. Alright? Let's try second example, part B. Ratio of females to males. Of course, there are 10 females. And we use our colon for 2. And the males are 20. So we're working with the same values. It's just that the numbers in the ratio are rearranged because we're doing females to males. So this is saying for every 1 female, there are 2 males. So the ratio of is 1 to 2. All right. Next question. The total amount of passengers, that should be the total number of passengers to males. And total number of passengers to males. How many passengers are there? There are 30. And how many males are there? 20. All right. And we can use the same 10 to simplify. And so we get 10 into 30 goes 3. 10 into 20 goes 2. So we get a ratio of 3 to 2. What is this ratio saying? It's saying for every 3 persons who come on the bus, for every 3 passengers that are on the bus, 2 of them are males. So if 3 persons enter the bus, 2 out of the 3 persons who enter a bus at any given time would be a male. All right, and that's what this ratio is saying. All right, so yes, suppose there were not 10 females or 20 males. This reduced ratio can say, all right, it doesn't matter the number of persons. Once there are passengers combination, there's a passenger combination of females and males, no matter the amount, it could be 20 females, all right, and 40 males. The simplified ratio would still hold true, right? And that's why we simplify ratios. We simplify ratios so that we can make a general comparison regardless of the total number that you're provided with. All right. I'll explain that in much more detail in the next example. Finally, the ratio of females to the total number of passengers. How many females are there? 10. Total number of passengers are 30. So that reduced to the ratio of 1 to 3. All right. So this is saying even if the numbers should double, even if you are given a different example, different number of persons, number of passengers, and number of females. Let's say you were given 20 females, right? That means that the number of passengers would be 3 times that, because the ratio is saying for every female, the number of passengers triple is 3 times that. So if it is that you have, let's say, 20 females here, right? If you had 20 females, let me just squeeze that in. All right, so if you have 20 females, that means that the number of passengers will be 3 times that. So 3 times 20 would give me 60. All right. If we had, choosing some random numbers here, if it is that we had 15 females, if we had 15 females, this is for argument's sake, that means the number of passengers would be 3 times that. So the number of passengers would be 45. So this simplified version of the ratio helps us to understand, right? Helps us to properly compare ratios, regardless of the number that you are provided with at the very beginning. All right, let's do a second example. All right, so in this example, we have a basket that contains 50 fruits. 15 are apples. All right. I'm just writing out the numeral so that we can better visualize. 12 are bananas, and the rest are grapes. So then, how can we find, excuse me, how can we find the value for grapes? We were not given the value for grapes, so before we even attempt the question, let's find what's outstanding. All right, so we have 12 are bananas and 15 are apples. So we just add those numbers together. All right, and since we know the total number of fruits, that's 50 fruits, we take the total from the 50. All right, so let me just do some quick maths. So we have 50 fruits in all, and we want to know how many apples and how many grapes. Sorry, we have the value for apples, and we have the value for bananas. So I just add the 15 and the 12, and that gave me 27. I apologize. So that gives me 50 minus 27, and that results in 23. So how many grapes do we have in all? 23. Awesome. Now we can solve our problem. Let's read part A. Part A says we need to find the ratio of apples to grapes. Now you're supposed to be glad that I found the grapes, value of the grapes. All right, so apples to grapes. There are 15 apples, 23 grapes. So let's write that in 15 to 23. It seems as if my clicker is not working. All right. Can this ratio be reduced any further? No. Because 23 is a prime number, it has no other factors other than 1 itself. So even if you use 1 to divide both numbers in the ratio, it will not be reduced any further. You'll have the same thing. Second question, ratio of grapes to bananas. There are 23 grapes and there are 12 bananas. All right, can this ratio be reduced any further? No. Let's do the third example. Apples to bananas to grapes. So we have 15 apples to 12 bananas to 23 grapes. All right, can't be reduced any further. D, the total number of fruits to apples. All right, so we have 50 fruits there. Awesome. And apples are 15. Now this ratio can be reduced much further if we divide both numbers in the ratio by 5. All right, so let me just put that in brackets here. So we're dividing both sides by 5, and that's supposed to give us 5 into 50 goes a ratio of 10 to 3. So this ratio is saying for every 10 fruits, that they put in the basket, 3 of them are going to be apples. So you count out, you're putting in fruits and you're counting 1, 2, 3, 4, 5, 6. So you go 1, 2, 3, 4, 5. Oh, the sixth one is an apple. Okay. 7, 8. Oh, this one is an apple. 9, 10. Oh, this one is an apple. All right. So for every 10 fruits that you put in the basket, 3 of them are apples. Continuing, bananas, the total number of fruits. There are 12 bananas and there are 50. All right. This can be reduced further if we divide both numbers. So I'm using my brackets to say I'm dividing both numbers by 5. I'm just using the bracket because I have no space to write the division sign at the top here. So I'm not dividing by 5, students. Oh my, I'm dividing by 2. I'm dividing both sides by 2. All right. 2 into 12 goes 6 times, and 2 into 50 goes 25 times. And this cannot be reduced any further, so we keep it as is. All right. And our final example, grapes to bananas, the total number of fruits. Grapes, that's 23, and that's 12, and that's 50, and it cannot be reduced any further, so we keep it as is. And that's how we write ratios and simplify ratios. All right, hope this helps.